Okay.
Recording in progress.
What?
I just recording the class. In case. All right, so let's do. Yep.
Every time I can hear an echo.
You can hear an echo.
I don't know.
I've muted this one. Is there an echo still?
Pardon?
Is there an echo still?
Yes.
Oh. I've muted my side. I'm not sure because my other device is completely muted, so
Yes.
let me know if it's if it's bearable. Let's just go with it. Hopefully it gets better over the class.
All right.
Yeah, because I'm not sure why. Because it usually happens when I have two devices that one of them is muted.
Okay.
All right, so recap. So last week was negative exponents. Recap what they were. So the important concepts. Firstly, let's go. I'll quickly give a summary. The first one is just being able to do negative exponents. Second one was power laws with negative exponents. And then finally, we did negative exponents in the reciprocal, the denominator.
All right.
So let's go through what basic definitions of negative exponents. So definition. Before we do that, let's do an example, right? Let's say we had 3 to the power of -4.
1/3 to the power of 4.
Yeah. What you do to simplify it and convert it to positive power.
1 over 4.
Yep, good. So I think you all got it. That's very good. Right. So this is the key idea behind negative exponents, is that we don't really know what they are initially. So we define them in terms of positive exponents so that we can easily deal with them. Right? And then we know how to deal with it. Now we know it's 1 over something, and it's just we can find out 3 to the 4 is. So in general, if you have a to the power of -b, it would become
1 over a.
Very good. All 3 of you got it. Very nice. This is a general idea, right? And let's just do a quick example where we're applying this. Let's do 16 divided by 3 to the power of -2. You guys to do this example. Same.
Also 144.
And I want you guys to use these ideas. Right? You finish, let's maybe do
Hang on, I'm a bit confused.
yeah, we're just doing the first one. Don't worry about this one. This is if you finish early. This is the only one we're going through.
Okay.
So I think the important idea here is to convert this negative power into positive power before you do anything, just so that you know what you're dealing with.
All right. So 1 to the power of 2.
Yeah. Becomes this. And then because you're dividing by reciprocal, it becomes
times.
108.
Yeah.
The second one, 108.
right? And then 16 times 9, you can just calculate that on your own, right? That's basic multiplication.
Yeah.
Right, so that
144.
should end up with 144 if you keep doing it. Right, but this is the key steps. It's just dealing with it by converting the negative exponent to positive exponent. All right. And then we'll go to power laws with negative exponents. The power laws itself isn't the tricky part. For some of you, it's the dealing with additions of negatives and stuff like that. That is a tricky topic, right? Some of you might be already on top of it, but it's just applying the power laws we learned before, like a to the power of m times a to the power of n would just be adding the powers together, right? And the division would be subtraction. Power of power is multiplication, so on and so forth. Those powers, those laws. We're just applying them in negative powers. So if you have something like, let's just do these 3 examples quickly. So recap: 3 to the power of -7 times 3 to the power of negative. Well, let's say
Plus negative.
That's one.
do it so that, and then power of 2 divided by 3 to the power of -2 divided by 3 to the power of -6. Let's do easy ones, just because we just warm up, recap the concept. And 3 to the power of -2 to the power of -3. All right, we just need to remember the power laws. Just multiplication is addition, division you subtract the powers, and when it's power of power, you just multiply.
Times them together.
Yeah.
The first one is 3 to the power of -11. Second one is 3 to the power of 4, and the last one is 3 to the power of 6.
Good. I'll give the rest of you guys a little bit more time. Then we'll finish up the recap in like another minute. Just got one more little thing after this. All right. Questions I want you to do. Here's the questions. When you finish early, I'll give you these. All right, we'll discuss it. If you can't read this, please let me know later.
Oh, we already did this class.
Your second answer, 2 and 3, you haven't done.
No.
The first one you did, remember. But do that again, just because good practice. Oops. Sorry, my bad, off accidentally. Okay, so let's go through these questions now. This is the recap. So when you add multiplying the powers, it means you're adding them together. So it's -7 plus -4 in the power. When you add 2 negatives, which way do you go? Right, when you add a negative number,
Yeah, you go to oh God.
to the power of -11. Oh, the left. My left, sorry. So it's your left. Because yeah, addition's right, but it's negative, so it's the opposite direction.
Yeah, it's left. Negative. If you pass a negative, write it down.
Yeah,
Minus.
yeah, -11.
Yeah.
Yeah, is that what you got?
Yeah.
Good. All right, sorry, I was confused. All right. Oops, keep stepping on the wire. Okay, was pretty bad. Because remember, we start at -7 and you go left. You're gonna get more negative.
Oh, yeah. No, I didn't get 3 to the power of negative. thought it was 1.
Oh, you got -1, 3 to -8.
Yeah, but now I get it.
Oh,
Go left.
yeah, you get the idea. So nice. And the next one is -3 to the power of -2 minus -6. Right? So because you're minusing the negative, there's a division, you minus, so you minus the -6. And if you sort of minus a negative, negative and negative is sort of cancels out, means you go right.
Yeah.
So-
it'll be positive.
No, because you start at -2.
Oh, 4.
Yeah, 3 to the power of 4. Is that what you got, Oliver? Oliver? You there?
Pardon, sorry, I just turned. Oh my god.
You got
The echo. I just turned it off. So I can-
Oh, okay, yeah, that's fine. But did these two, you got these two? Make sense?
Yes.
Okay, good. And finally, this one's easy. Power of powers multiplication. There's 3 to the power of -2 times -3. 3 to the power of +6. Negative times negative.
Pardon?
So when it's a power of a power, you multiply the powers.
Yeah.
And that's negative times negative, it cancels, becomes positive, +6.
The positive. So that equals 6. Yeah.
Yeah,
Three
you
to
don't
the
need to
power.
find what the number is, just leave it 3,000. All right, good. Finally, we do negative exponents in the reciprocal. So, it's a shame. In the one little section as well to do these first. So we have now we're gonna have negative exponents, but they're instead of being at the top, they're at the bottom of the fraction. So normally we've seen stuff like 3 to the power of -2 at the top. But now we're gonna go to negative exponents in the reciprocal, meaning something like this. Right? And then sort of think like there's two ways to think about this. So when we had the negative exponent up the top, we brought it down to the bottom by switching where it is. So we can think of the same logic. If it's at the bottom, it goes back up. Right? That's just sort of a shortcut way to remember that. Right? It just becomes positive power, but up the top. It just switch places from the bottom to the top, from the denominator to the numerator, it becomes positive power. That's one way to think of it. God, this is so weak. Okay, so then another way to think about it, this is a proper way to think about it, is this. Remember, fraction means division, right?
Yeah.
So all we're doing is 1 divided by 3 to the power -2. Agreed? Makes sense? And then
Yeah.
there's one-
So kept that all and then. Oh my god.
sorry, you cut off a bit.
3 to the power of 2.
Yeah, but let's just do the steps as well. 3 to the power of -2 is 1 over 3 to the power of +2, remember? From what we've done before. And then, because you're dividing, keep change flip. You flip it. 1 times 1, 3 to the power of 2 over 1. Okay? You bring the denominator to the top. It just becomes 3 to the power of 2. That's the proper way to think about it. But obviously, you're not going to do this every time you do this. When you're doing questions, you should be thinking just like just flip it. But the proper logic is here. But you don't need to use proper logic every time. If you have a shortcut in your mind, you can use when you do question. Right? So if you have something like, let's do some easy examples.
And then it has times, then it will go in the question.
Sorry?
In the question, it has a division instead.
I'm so sorry, you keep cutting off a bit. It's very hard to understand.
If you have a time.
Yep.
In the question.
Do these ones. Yep. Oh, times in the question. What about it?
It changes to a division.
You change to a negative.
Speaking of that, echo doesn't happen.
It depends. I think you can do both ways. You can do change to positive as well, because usually positive is a bit easier to work with.
Okay. Okay.
Maybe I misinterpreted you. What do you mean by change to a negative power?
No, so like
No,
when you
so like
do
when you do the
change the
change the Would you maybe put in chat because you keep cutting off, so really I'm not sure. Sorry. Okay, let's do these questions and then we'll go to the content today.
The first one is 4/3, and the second one is 1 to the. I don't write it down, I'm just thinking about it.
So in that one, remember when you have power, the power applies to both numbers. Yeah. The power goes to sound. And the brackets will go away.
Right. You turn your phone back on.
Also it is 0.7. 0.7. In this case, for example A, what happens is this power of -3.
Yeah, so it's 4 to the power of 3.
Yeah, followed by +3 switches, right? For B, the important idea is because this -4 applies to both numbers, applies to the whole whole fraction, we'll go to both numbers first.
So it's 1 to the power of 12.
1 to the power of -4.
No, 1 to the power of -4, then 3 to the power of -4.
Maybe 1 to the power of -4.
Yeah, over 3 to the power of -4.
Oh,
Because the full power go to both numbers. And then
oh,
after
then
that,
you switch it.
yeah, and then you switch it over 1 to the power of 4. And 1 to the power of 4 is just 1. So 3 to the power of 4 is the answer. So the important here was to switch them. Yeah, one at the top goes to the bottom, blah, 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 and then it's 3 to the power of 4 in the end. Okay, good. Let's go to today's content now. All right, so the topic we're doing today is number theory. Okay?
What's that? What's that?
Number theory is the study of whole numbers or integers. This is obviously, this is like this goes all the way up to university level, but we're going to learn the basics of number theory today. Because what we want to be, we want to be experts on whole numbers before we go into fractions and decimals. Right? I know you guys already done fractions and decimals probably a little bit at least. But the important thing is we want to be experts on whole numbers before we go into this. So we're going to learn stuff like multiples, multiplication, divisibility rules. Like how do you know something's divisible by 3? Stuff, blah, blah, blah. We're going to learn this other one. We're going to learn prime numbers, a lot about prime numbers, prime factorization. We're going to learn something called lowest common multiple, highest common factor. There might be something you've learned, but we're going to go to a deeper level. So and be like, oh, I already know this. I don't need to worry about this. Okay. So let's begin with a little practice on the concept of remainder, which you've probably already seen. I'm sure all of you probably seen remainder before, but I just want to quickly sharpen up on it before we go to today's concept.
Yeah. You've all seen it.
Remainder, I mean, I'm not going to really explain it properly. It's just quick recap. When you do the division, the number you get left over is the remainder. And the number at the top is a quotient, right? The answer sort of, the whole number part of the answer. What I want you to do is actually, do you guys all know remainder and quotient? Yes. You don't even know the name, you know what it is, right? Yep. So I want you guys to do part A and C. If you finish early, go to B and D to find the quotient and the remainder for all the following divisions. So part A and C we're doing.
What dear Lord? See.
Oh,
Is that the same number? Because I don't know the number before, I think it's not that. We do long division.
I'm confused that I haven't done that division like since year 4.
Basically what this did this here, right?
Yeah.
Split the big numbers.
7, so there's 7, then
Oh.
0, and then you drop the 3.
But because there's 1 here, this means zeros. Because it's 10th place. So there's 0, 0 ones, so it's 0 there.
Oh.
Because it's 10th place, you've got nothing after that, it's 0. No, 1 at the top, set, the units place is 0.
Oh. I didn't do it with the
Oh, the answer's 10 remainder 3.
Yeah,
colors.
yeah, that way is correct, but you got the exact answer, right?
Yeah, this is the exact answer. But if I got rid of these, I would get a remainder of 3.
Remainder equals you got the exact answer. That's the answer. Remainder is 0. Because there will be a remainder. Otherwise, it won't be the exact answer.
I'm confused because now we go into like the decimal place where we aren't doing
The second one doesn't
Yeah.
have a remainder. Though.
Yeah, because when decimals remain doesn't mean much. Yeah,
Does the second one have a remainder? I got 212.
there's no remainder. Remainder 0.
Yeah.
So the answer is this one's 10 remainder 3,
What's 212?
and this one's 212 remainder 0. Right? I know remainder is kind of useless when you get to decimals and stuff, but when it gets just with whole numbers, just with this study, yeah, it is kind of useful.
How do you calculate?
Yeah. C.
Yeah.
Okay, I'll go through C. Good. If you ever confused, ask. That's very good. So what you do is, okay.
Oh yeah.
Yeah.
Never mind.
Yeah, got it. All right, easy. You're gonna learn. Actually, I'm gonna skip this symbol. It's not that useful. Right. Now we're gonna go to what multiples are. So, do you like multiples, Emma? That's good. Multiples are when A and B are numbers. A is considered a multiple of B if A equals B times another whole number. A whole number is really important. It can't be like a decimal fraction.
So A equals B times 5. So that's it.
Sorry, could you repeat that? A equals B times?
Times something.
Yeah.
Yeah.
But the something has to be a whole number.
Yeah, it has to be a whole number.
Yeah. And then it's a multiple. So for example, I will do something like, for example, 24 is a multiple of 6 because 24 is 6 times 4.
Okay.
Yeah. Can you guys come up with an example yourself? Multiple? Or something like, give me a number and a multiple. Something's a multiple.
3 times 20.
What's that?
4 and 12. I mean,
That's
12
6.
Yeah. One example we got is 12 is a multiple of 4, right? Yeah, 15 is a multiple of 3. Right? Yeah, the concept is an important thing, right? But also another way to think about it is we got this one already down. You guys already know this one. A equals B times another whole number. But another way to think about it is when you divide A by B, you get a whole number with no remainder. Right? When you divide 24 by 6, you get 4, remainder 0. Right? When you divide 12 by 4, you get 3, remainder 0. So another way to think about it, I think it's multiple. So this second definition is really important for checking if a number is a multiple of another, right? So what we do is we check whether the second number is a multiple of the first number here in this example, by dividing them together. Does that make sense? And that's how you can check. But before we do this example, what I want you guys to realize is here, I said n can be a whole number, right? N is a whole number. We're multiplying whatever you multiply b by is a whole number. A is b times a whole number. But I never said it can't be negative. Right? So it can be negative. So another example would be like negative 12 is a multiple of 6. Why? Because negative 12 is 6 times negative 2. So negative numbers are also multiples. And you can have multiples of negative. You can have, or 12 is a multiple of negative 6, also another example. Because 12 is 6, negative 6 times negative 2. So it can be negative and stuff. But
So negative times negative.
even that's even negative times positive, any sign, the signs really don't matter as long as the answer is a whole number.
Right.
So okay, I think do you think whole numbers are negative only or positive only? Is that no negative whole numbers as well, right?
Yeah.
Okay, then that's fine. That's then the whole. Okay. So now we're gonna check in this example. We're gonna check if the second number is a multiple of the first number. We can do this by division. So what I want you guys to do is do example part A. Actually, we'll do it together. C. Yeah, A and C will do it together, right? We're
Alright.
gonna check if the second number, just like this one, is a multiple of the first number. So we're gonna check if 24 is a multiple of 12.
And that's 2.
Yeah, that's true, right? Because 24 divided by 12 is 2 exactly, no remainder. 12, add another 12, 24. That's 2 12s. So because it's 2 with no remainder, yes, 24 is a multiple of 12. What about B? Negative 5 and 35. Negative numbers are allowed, right? I know, yeah, you guys probably haven't seen negative numbers in school because they only work on the positive parts. But by definition, negatives are allowed. So 35 divided by negative 5
Negative 7.
would just be negative of whatever 35 divided by 5, which is 7. No remainder. Right, exactly counts. Negative 5, negative 10, 35 is there. So yes, this is also multiple. And what about negative 622 and 27? Do long division.
54, 1, plus 2.
So you can ignore the negative really, because you can always put a negative at the end. Yeah, so you can just do long division with the positive numbers and then put a negative at the end if you need. I'm going to do 622 divided by 27. Is that multiple? 622 is multiple 27. I want you guys to check on your own. 27 is 54. I think that's 2, 27, 62.
So there's 82. No. I haven't done the remainder, I just figured it out.
Oh yeah, either way, as long as you know the remainder is not 0, right? All right, the remainder is not 12. Because actually knowing the remainder is kind of useful later on. So
1.
you have 82 here, right? 27, 54, 81. There's 3 27s. Because one was 108. There's 27 times 3 is 81. If you take away 81 from 82,
The remainder is 1.
remainder is 1. Very good.
2.
Oh, I did it wrong.
Do you know why you do it wrong though?
Yeah, because I accidentally did that.
I got
Yeah.
the better one as well.
If you understand,
Yeah, I put the numbers together.
oh, okay, but you get it now, right? Yeah. As long as you understand how the remainder is actually 1, it's important. All right, so remainder is 1. Therefore, it doesn't divide exactly. Therefore, no is the answer. So now I want you guys to do it alone in these examples. Gonna do A, C, and E. Oh wait, sorry, A, D, and F.
Out of
You guys are pretty strong. Give you the 2 hard ones. Oh no, wait. Yeah, I hope none of you are F. Don't do F, do E. Sorry. I just realized.
He's the
You can do it like that way as well, but you can do the remainder. We can also just like see it. It's not right. Right, 16 divided by 3. Don't think you need to do long division to know it's 3 times 5 is 15. Right, so it's 5 with the remainder of 1. The answer, therefore, it's not 16 is not a multiple. If you go to D and do long division, right? 89 goes into 23 how many times is the question? Because 8 obviously doesn't go into 23 at all. We're gonna see how many times 89 goes into 23. So 23, 46, 69, 92. 4 is too big, that means 3 is the smallest. 3 is the largest number that goes into 89.
and then there's
20.
20 remainder.
23 times 3 is 69.
20 remainder.
Yeah, 20 remainder, carry the 7 down.
39.
Yeah, and that's a bit tricky, but it's actually 9 exactly. 23, 46, 69, 92, 115, 138, 161, 184, 207. That's 9 exactly. So very good, Oliver. So it is 9. Right? And 39, there's no remainder because it's exactly 207. The remainder is going to be 0. Therefore, the answer is yes. This is a multiple. And if you go to E,
Because 12 times 12 is 144. 1 remainder.
we can also see this is even, this is odd. Clearly can't be multiple, right? No, but it is important that you still be able to do the remainder as well, just because later on that idea is really useful. Right? Remainder is
1.
yeah, 1. All right, let's go to this exercise I want you to do on your own. So I'm not going to explain too much of this. Pretty simple. Maybe B and B from B on it gets a little bit weird.
No, just
Negative. Large negative means like negative 1 is bigger than negative 2.
yeah.
It's like the smallest numbers really. gonna do A. You do all 4 parts. Gonna learn. So what's the smallest positive multiple of 9?
One.
No.
3 times 3.
No, it's 9
Or
times something. 9 times
9
small-
just 1.
9.
Yeah. Oh, we're doing the first one. Oh.
Yeah.
9, 18, 27,
Yeah.
32.
First smallest one's 9.
Five.
Then it's 9 times 2. Then it's 9 times 3. You just keep adding 9.
Alright.
And see how you went the other ones. So it's 9, then 9 times 2 is 9. Add another 9. Keep adding 9s and you get 27, 36, blah, 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 blah.
Until you at 90.
And then for part B, 10 largest negative multiples of 7. Here's the trick. Largest is actually not going to be largest. It's largest negative. So large negative is like a -1 that's bigger than -2. So you actually want the smallest values of the negatives.
So the first one is -7.
Because 7 times -1 is -1's the largest negative number. So -7. And then you just keep going down from there.
15, 14, 15.
So
Very good. Keep adding or adding 7 or subtracting 7, really. 28, so on, blah, 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 blah. All the way to a -70. Good. Okay, then we do.
19.
Ten smallest positive multiples of -19. If you can figure out what the smallest one is, you're just counting out from there.
Will be -19, -38, -59.
No, positive 19. 10 smallest positive multiple.
19 positive.
Because it's -19 times -1 is positive 19. That's the smallest positive multiple. So it is a bit of tricky because the number's 19, -19, but we're asking for the 10 smallest positive multiples. Right? So it starts at 19.
19, 30, 50,
Because 19 is -19 times -1. So it's a multiple. So
78.
does that make sense, Oliver?
Yeah.
Yeah, good.
So you want 19, then
38.
then
Blah, 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 blah.
38.
107, 100. 100.
It's a bit tricky because adding 19 is kind of annoying.
Yeah.
But it's good for good practice for arithmetic.
20, 35.
Careful is good, I guess. You're not careful, it's very easy to make mistakes. Should go down 7. Taking 9. The years should go down 1 each time.
Oh,
It's common to make mistakes.
should we make one mistake?
Remember when you add 9, each digit goes down by 1. So 19 and goes to 8, 9 goes to 8, 38. 8 goes 7, 57. Also think of it like this. Add 20 then subtract 1. Adding 19 is the same as adding 20 then subtracting 1. Thirty-eight plus 20 is 58. Subtract 1, that's 57. And D will skip actually. But the same idea. Finish early, go for it. Oh yeah, you'll skip D. Looks good. Although, what are the first 5 numbers you got?
First five numbers for A,
For C?
for C.
We're still doing it.
Still
Fine.
working. It's pretty hard.
Okay, yeah.
I found the
It's fine.
It's 2 plus for each one. The first number.
19, 38, 57,
Good.
then 76,
Lose one. You said go down one.
76,
Minus 176.
and lastly
19. You're very close. You only 3 off all the numbers. You did everything right after here.
95.
57 at 19.
Negative 95.
Plus there.
But after you had everything else, you just keep playing through all of these. Yep, you got 76, 95. Sorry, I missed after that. Did you say?
I said 76, 95.
I'll write the rest down. You don't need to find if you haven't got it. 114, 133, 152, 171, 19. Right? That's that. Okay, good. So that's the key ideas. But now we're going to go to, skip D. You can, if you don't know, that's good. Now we're going to go to this important property of multiples, which is the addition property. Some of you might probably haven't seen too much of this before, right? So what I want you guys to do is give me 2 multiples of 7. Any 2.
14, 20,
Now give me something a little big. This
49.
49.
63.
Yes. Good. We'll do a little. Let's do 3. Give me even another one.
42.
42. All right. Okay, I'm going to do just 2 of them first, then I'm going to add the third one in. Right? I'm going to do 49 and 63. Both multiples of 7. Now, I want to know whether if I add these 2 numbers together, 49 and 63, is that a multiple of 7? So, no? We don't know. We need to figure that out. Right? We'll do it together. 49 plus 63 is 100 and think 1212. Divide by 7. Right? 11. 7 goes into 11 once. 1 times 1 is 7. Carry the 7 down. 42. 42 goes in 7.
Yes.
6,
I
16.
just continued the pattern on the other page.
Oh, okay.
That would be 7 times
16. Because 42. Yeah. Right? So the important thing is it's 7 times 16. But look at this. This is 7 times what? It's 49 7 times?
7.
7. 63 is 7 times?
9.
9. And when you add them up together, ends up being 7 times 16, which is 7 times 7 plus 9. You're literally just adding up these 2 numbers together. So 7 times 7 plus 7 times 9, 7 times 7 plus 9. So it stays as multiple 7. It's an important thing because you're just adding 7 sevens to 9 sevens, so it's 16 sevens in the end. So if 2 numbers are multiple 7, when you add them up together, they also say multiple 7. Now we're going to generalize this idea, right? Actually, I'll use your number as well, Oliver. What do you think happens if you add 42 to this 112? Yeah. It's 7 times what? So we have 7 times 16 here, 112. Getting 7 times 6, right?
Yep.
If you had 7 times 6 to 7 times 16, you end up with
154.
yeah, but what's 7 times? 1 to 54 was correct. It's equal to 7 times.
7 times
I think. Oh, you're almost there.
17.
No.
No, not
16, then you had 6.
20.
Close. It's 6. 16, and then 6.
16.
22.
22. Yeah, very good. 7 times 22. So you don't even need to calculate. It's because it's 16, 7, 6, 7. Add them up together.
Looking for the number at the back, so it's a 7. So you just have to find 2 or 7.
All right. And here's the idea. Now we're going to generalize this to any number. Right. Here's the important theorem. If A and B are both multiples of C, right? Then A plus B is also, no, sorry, not are both, is a multiple of C. Right? If A is a multiple of C, B is a multiple of C, you add them together, it's still a multiple of C. And here's the proof. All right, important proof. You have, let's say, if A is a multiple of C, A is C times some number M, right? Some whole number M.
Yeah.
You agree? And B is also C times another whole number. Let's not do M because they're the same whole number. Let's do N, right?
Yep.
C times M, C times M. This is the proof, yeah. And then if you add A plus B, you have C times M plus C times N. And is this a multiple of C?
Yeah,
Why?
because you're just passing the one, you're just adding the two together.
Yeah.
Yeah,
This-
yeah.
You can distributive property.
Yeah.
Yeah. The distributive property is C times M plus N. You can take out the C and it's C times M plus N. Right? So in that case, this is a whole number as well. So it's still, I think, just like that before when we had 7 times 7 plus 7 times 9, that's 7 times 7 plus 9. 7 times 16. Right? All right, now we're going to go to an example. Let's do this together. Right?
The first one's yes, I think.
Yeah, let's see. That's good. Suppose 7776, Imam. 7776 is a multiple of 18, right? So that's all. You don't need to check it. You just assume it's true. Right? I've given it to you. When asking you, is 7776 plus 18 a multiple of 18?
Oh,
Yes,
Yes. And why is that?
because 18 is just like,
you're just adding another one.
yeah.
This is a multiple of 18. This is also 18 is obviously a multiple of 18.
Yeah.
You're adding 2 multiples of 18. That means when you add them up together, it's still going to be a multiple of 18.
Yeah.
That's this theory we learned. By this theorem. So yes.
But the second one is no.
No, because there'll be a remainder of two.
Does that make sense, Oliver? Part A?
Yep.
Good. And B, suppose 14292 is a multiple of 6. If you add 32 to it, is that a multiple of 6 anymore? No, right?
No.
Because 32 is not a multiple of 6.
Yeah.
Because 32 is 6 divided by 6 has a remainder of 2. Yeah, that's what you said, Imam. So the answer is no here. This is a multiple of 6, but this is not. So this is what fails here. If you had 2 multiples of 6, it would remain multiple of 6. All right, good. Now we'll go to this exercise I want you to do on your own. Just do a part A, C, and E. And you finish early, obviously do B and D as well.
So 18 what?
Sorry?
AC and what?
A, C, and E.
Can't find that.
Can't find it.
I can't find the page.
It's page 7.
6, 7. No, my page is different.
Oh, really? Oh, did you print it early? Because I did make some edits to mine because I improved the handout after yesterday's class. Maybe just look at the board for now and let me know when you need to move on.
Right.
Yeah, sorry about that.
How is R and S even multiples of 9? There's no even multiples of 9.
What do you mean? 18.
A is yes.
Okay.
As and here is A.
Yeah, that's great. How do you know multiple 13? Yes. Why not? But it's not. Why is it one? Why is it not this? Okay, the thing with these sort of questions is there's only a limited number of options, really.
1, 2, 4.
Like how many square numbers are between 100 and 200? Question 1. Actually, not that many. If you can. Write down all the square numbers first, then maybe you can see which one's a multiple 7.
Oh yes, the last one yes. First it could be 18 plus 36, 54.
Yeah.
18 times 3 is 54.
So yeah, go to challenge questions if you know. Next page. All right, let's go through these ones. Oliver, how'd you go with part A?
What's a perfect square?
It's like 4 times 4 is a perfect square. 16.
Oh,
Any number that's can be multiplied. So for that one, hint would be think of all the perfect squares and see which one actually satisfies.
So question C.
Yep. How'd you go with A? Yes or no?
Oh, A is yes. You can multiply.
Yep, because this one's multiple of 8. We already know that. And 88 is 8 times 11. So yeah, that's yes as well.
Yeah.
Good. All right.
is 5 times 5 a perfect square?
Yeah, but look, our guide range is 100 to 200.
No. Question C.
Good. Because it's 40, right?
Yeah.
40 is not a multiple set. And E? So what's the smallest square number that's bigger than 100 or bigger than or equal to 100?
I'm confused.
So this one's a bit tricky. Square means multiply by itself. Right? So suppose R and S are even multiples of 9, right? We don't know anything about 18. We don't know anything about 18, but when you add these up together, you know it's multiple of 9, right?
Yeah.
R plus S is means multiple of 9, right?
Yeah.
But we know that they're even.
Yeah.
When you add two even numbers together, is it gonna say even?
Yeah, stays even.
Stays even. So this is even and a multiple of 9, R plus S.
Pardon?
R plus S is even and a multiple of 9.
Okay.
But 18 is 9 times 2. So anything that's even, which is 2, and it's 9. We already got the 9 power. We already got the 2 power because it's even. So this also will be multiple of 18.
Okay.
Does that make sense? Because 18 is 9 times 2. And because of that, it's multiple of 18.
Okay,
it's given.
okay.
All right. Now we'll have a 5-minute break, right? And then we'll continue. Yeah, give you guys some hints for the challenges.
There's only 11, 12, 13, 14, between 100 and 200.
I was thinking one, like, I thought the multiple, but and I had to do that one, but
The twos.
Huh?
Perfect square part.
yeah.
Oh, think of one perfect square between 100 and 200, smallest one. Just do give a number and square it and see if it's bigger than 100. So like 1 squared is 1. It's too small, right? You can go higher.
50.
50 squared.
Oh wait, no, that's too much.
You wanna pick, find all the numbers, square numbers.
Okay.
11 squared? 7.
11 squared would become 1, 121.
Yep, you got a reference. So it might not work, but you got a reference. You got one square number. And see if you have anything smaller in that range. 1 squared, is that good? 100, 100. Okay. You just keep going up 1 until you get bigger than 200. Okay, or you list. So you can do is you list all the squares between 100 and 200. So one really important also strategy is listing out the possibilities, then eliminating them. So you got 100, you got 121.
11, 12, 13, and 14.
Yeah, 12 squared
It's
is
144.
13 squared. Calculate that.
169.
14 squared, calculate that. Until you get to the upper bound. And you only have 3 possibilities. You just need to check if they're multiple of 7.
Oh.
Does that make sense?
Yeah.
14.
So, although we're not going through the challenge, if you want, I'll give you some hints just because move on to the next section of content anyway.
Okay, okay.
Give them a crack and tell me any hints you want. They're optional, but they're good for your.
The answer is 14.
Let's not spoil it. That's that. We're not do it as well. But that's not the answer. But you know you got the answer. Don't say that. I want to get it.
Okay. So who was that? Did I have a question?
There's actually another shorter way to do question 1. A really quick way. Because it's a square number, the 7 has to come from within the square itself. The number you're squaring also has to be multiple 7. Does that make sense, Emma? You can actually not even need to go through all of that. You can.
Is there any 121?
The dividend by 7. Except the remainder needs to be 0.
Can't enough, don't you?
21 goes to 7, but 121.
Oh.
Just because it's 21 doesn't mean 121. There's one more number you're missing in the 100 too. You got 13 squared. You think 14 squared is too big, or is that still in the range? The idea of remainder is really useful for question 2.
Pardon, I'm very 1 and 2. 1 and 2.
1 and 2 you want help with? Yep. So
Yes,
my
yes.
hint for you is there's 2 ways to approach this, right? because a perfect square, right, between 100 and 200, there's only a few of them. Actually, only like 5 or 6 of them. I don't know exactly, right? So you can just find out all the perfect squares in that range and find which one is a multiple 7. Does that make sense?
Yeah.
That's one way to approach it. I'll give you the second way later because it's a bit more tricky. And then for question 2, use remainders. Try the biggest number, see what the remainder is, and then you can maybe bring it down to the remainder is 0. Do question 1 for now. See how you go with it. The thing is, this is not. There needs to be 7 in numbers to multiply.
Oh, so just go from
Is there 7 in any of these? This is 2 times 5.
is there 7 in 100?
No, is there 7 in 10 because it's going 10?
Oh yeah. One.
No. It needs to be exactly. It's a factor. No.
Oh,
2 times 7. 7 will multiply into.
oh,
Or we can also check individually one by one.
yeah, 7.
That's an easy way to do that way.
That's so easy.
Yeah, once you get it, it's really easy to see. That's what problem solving is. Reset the technique. Yeah. So for question 2, my hint for you guys would be, what's the largest 3-digit number? Check that, and you might, it's not the answer. I'll tell you right now, it's not the answer.
Yeah.
Right? But checking that will actually give you a hint. If you check if it's a multiple of 13, you'll get the remainder. How's the remainder held?
Because you take it away from. Oh,
So you start at the biggest possibility and then you break it down. Did that make sense, Oliver? The hint for question 2?
Yeah.
Good. Did this other approach question 2 make sense?
Question 2.
Your answer is correct, but
Yeah.
you know, how's that a different approach?
Yeah.
Makes sense?
Yeah.
This way I find remainder is really important. And I'll probably do a long division just because then you can find remainder easier.
yeah.
Yeah.
Understand.
No. I'm not saying it. Question 3 is a bit of a trick. A. Oh wait, no, never mind. You're good. Sorry about that.
Tiny. Would you need to take away the actual answer?
Actual remainder. Final remainder. It's, Thirty times 7, 91.
91.
38 plus 30. Do that again. right, we'll leave the challenges for now. We'll go to the content now. Right? I'm gonna go to divisibility tests. Okay. So, sorry, what was I gonna say? So we're gonna learn some divisibility tests, like quick way to check if a number is a multiple of something, right? And I know some of you've probably done some of these already, but I want you to become really good at it. This is the point of this section, right? Because when you go to prime numbers, these divisibility tests are really, really important. It's just getting in the way. It's getting in the way. Okay. Yeah, move it out anyway. So we're gonna define a new term, which is divisible, which is basically saying, which is like same as multiple, right? It's basically means if A is a multiple of B, another way to say it is A is divisible by B, right? So if 24 is a multiple of 6, I can just say 24 is divisible by 6, right? Or I can say 15 is divisible by 5. It would also be. There's one exception. Not really important exception, but I just want to make you know there's exception to this. Do you think is 0 a multiple of 0?
No.
Why not?
Oh no, yes, because if you add 0 plus 0, the answer is 0.
Yeah, but also 0 is 0 times 1, 0 times 2.
It's
Oh,
just 0.
Yeah, 0 times any whole number. So there's a multiple.
Even if you times it like a million times,
Yeah.
it's just 0.
Is 0. So 0 is a multiple of 0. That's correct. But you can't say 0 is divisible by 0. Because remember, you're not allowed to divide by 0. So you're not allowed to say this is good. 0 is multiple of 0. Correct. I agree. Right? But you can't say 0 is divisible by 0. Remember, dividing by 0 doesn't make sense. Just the number one rule in math when you get to algebra. A lot of mistakes a lot of people make is because they accidentally divide by 0 somewhere. Right? It's in algebra, so that's a long time away from me. But number one rule in maths, don't divide by 0. Right? So you will never say something divisible by 0. So this is wrong. But yeah, this is exception. So it's like in a very rare case. So you're not probably gonna ever worry about this. But for all other purposes, multiple and divisible are basically the same thing. Right? Okay. Now, in the last section, we learned to check if a number is a multiple or divisible by another number. How do we do this? How do we check if a number, if I want you to check 623 is divisible by 23, how would you do it? Is a multiple 23?
You will divide.
Yeah. We did this by dividing. And what do we check for?
If it's
Start with R.
remainder.
Yeah. Remainder is equal to 0. I'm gonna check if remainder is equal to 0.
Yeah.
If the remainder is 0, it's multiple. If not, it's not a multiple. Right? But the thing is, this method is quite long. Right? And for some special numbers, we have shortcuts to check whether they're divisible or not. Okay? So we're gonna go through the shortcuts now. So I'm gonna quickly go through all of them, and then we're gonna go through in depth a little bit more on each of them, right? So first, for 1, all whole numbers are divisible by 1. So you don't really need to check that, right? Everything's divisible by 1. Everything's a multiple of 1. To check if a number is a multiple of 2, we just need to check the last digit. If the last digit is divisible by 2, it's even. Then number is divisible by 2. Right? And for 3, to check if it's divisible, you add up all the digits. Right? For example, 765. We would add up 7 plus 6 plus 5. That's 18. See if it's divisible by 3. Is 18 divisible by 3?
Yeah.
Yeah. Because of that, 765 is also divisible by 3. Does that make sense? We'll go through this more in depth later as well, but just so for now, sort of get what it means. And the next one is for number 4. For checking numbers divisible by 4, you just got to see if the last 2 digits are divisible by 4. What I mean by that is if you have like a huge number, let's say, I don't know, 1, 2, 3, 4, 7, 6, 7, 8, 8, 1, 3, 4, 8. Is this divisible by 4?
Yes,
Why?
because 48 is 4 times 12 is 48.
Yeah, you only need to check the last two. 48. 48, like you said, Sashan, is divisible by 4. 40 is 4 times 12. So only the last two digits matter. So it doesn't matter. Can I have any number? I can really change anything in the front. So if the last two digits are divisible by 4, it's 4. It's multiple of 4. But if it's not a multiple of 4. Right? And then for 5, pretty easy. The last digit is 5. 5 divisible by 5 means the last digit is either 5 or 0.
Yeah.
If the last digit is 5 or 0, then it's a multiple of 5. Right? As for example, if I do the same thing again, blah, 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 something ugly, 8, 9, 5. That divisible by 5?
Yep.
Yeah. It doesn't matter what's up the front. The last digit is 5. Yeah. Even if 0 would also work. Anything else, not a multiple of 5. And 6. When you want to check if it's a multiple of 6, what do? We combine the rules for 2 and 3 together. So you just need to check if the sum of the digits are divisible by 3, and also check if it's even. Right? So that's pretty easy. For example, this one, 765, wouldn't work because some of the digits are divisible by 3, but is it even?
No.
No. So therefore, it's not a multiple of 6. Right? Any questions so far to this point? No? All right.
What's wrong with 7?
7, there is a divisibility rule, but it's really ugly. You don't even bother. If I can say it if you want, but
Yeah.
I'll give it to you just because you're curious. What you do is remove double last digit. Like, shit, let me just Google how to explain it because I want to explain to you nicely. Okay, so if you subtract twice the units from the rest of the number, it should be multiple 7.
Subtracting twice.
Twice the units digit, sorry, units, like the ones digit.
Yeah.
From the rest of the number, it should be multiple 7.
Oh,
So what I mean by that is I'll give you an example. Let me think of.
so wouldn't that be hard for like bigger numbers?
You just keep doing that though. So I'll show you like a big one. 12, 8, 3, 4, right? What you do is you double this number, which is 8. Take that away from 12, 8, 3. 12, 7, 5. Now you're gonna check this is divisible by 7. Double this number,
Yeah.
take it away from 127. 127 minus 5 times 2 is 10. 117. Do the same thing again. 11. Well, okay, 117 you can check pretty easily, but you can also do 11 minus 2 times 7, negative 3. Negative 3 is not a multiple of 7.
Yeah.
So it's not a multiple of 7. So you can just keep reducing the digits one by one. But it's not necessary. You're not going to need to do this. Right? It's just if you're curious, you can do this, but yeah, it's not that useful. Probably just do long division.
Yeah.
Yeah.
Way easier.
8. A number is divisible by 8. If its last 3 digits, it's divisible by 8. So if I give you something like blah 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 1 3 1 2 8 4 9 3 1 5 0 2 4.
Yep.
Is this multiple of 8?
Yeah.
Yeah.
24.
Yeah, 24 is multiple. Good. Did this make sense for you as well, Oliver?
Is he even there?
I hope so. Oliver?
He's muted.
Oh, he's muted. He's probably saying something.
Oh, sorry, I was muted.
Yeah. So did this make sense?
Yes.
All right, good. And last two, right? Multiple of 9 to see if it's multiple 9 or divisible by 9. Just gonna check if you add all numbers together, it's divisible by 9. Right? You're gonna check if the sum of the digits is divisible by 9. So for example, we'll go back to this one, 765. Before, if you add them up together, digits, what is that? 7 plus 6 plus 5 is?
18.
Yeah, 18. Is that divisible by 9?
Yes.
18, 9 times 2. So yes. So it is divisible by 9. So this one's good. That's one we check. And then the 10 is really easy.
Yeah.
The last number is 0. It's divisible by 10. Everything else, no. So, again, I can put something really ugly in front. 7, 3, 6, 5, 4. Multiple of 10. Yes or no?
No.
No. You'll put a 0 now? Yeah?
Yeah.
Yes.
Yeah.
Right?
Yeah.
So that's 10. Right? And I put them into three colors. There's 3 categories, right? All the blue ones are like multiples of 2 stuff. 2, 4, 8. And also it would actually continue for 16, 32, but it's so long, you don't have to worry about it. And 3, 6, 9 also the same rules. Very similar rules. And 5 and 10, super easy rules. Right? Last digits only 1 matters. Right? Okay, there's some easy divisibility rules for other numbers as well. But they mostly build up from the basic ones we learned here. Right? So for example, can you give me, what do you think another one number we could know the divisibility rule face?
What do you want?
Just give me a number you think the divisibility rule, there would be easy divisibility rule for. That's not in this list.
11.
11, unfortunately, not as easy. 11 would be whole separate.
No,
Oh yeah, after I had really good side up.
You are correct.
only 15.
You know what 15 is? You combine the 1 for 3 and 5 together.
Yeah.
15 is really easy.
Yeah.
3 and 5. Right, you just gotta check the last digits 5 or 0. And then you also gotta check if it's a multiple of 3. So you do check all the sums add up to 3. So 15, all you gotta do is check if some. Sorry, what was that, Oliver?
Everything that can be divided by 5.
Yeah. 3. And so this is the divisibility rule for 3. And final digit is either 0 or 1. It's 0 or 5, sorry. These are 2 rules combined. And actually, one of the questions you have, I think 18, you got to figure out on your own. So yeah, I'll do that on your own later on. Okay, now we'll go to divisibility rules for 2, 4, and 8. So a number is divisible by 2 if you, like we said before, if what? What's
Even if
yeah,
even.
or what's another way to say it?
The last digit is divisible by 2.
Yeah, or you can say last digit is even.
Okay.
Or 2 either way. And Ima, what would be the rule for divisible by 4?
If it has a 0. No.
That's 10.
It's
It's
divided by
divided by
4.
Sorry?
It's divisible by 4. Two digits are divided by 4.
Yeah, last 2 digits.
So let's say 2, 9, 4, 6, 8, and then 4.
Yeah, that would be one. I think you said 8, 4 at the end, right? That would be multiple of 4. Yeah.
Yeah, yeah.
Good. And then Sasha, what's 8?
8.
8.
2 and 4 combined.
No.
Oh.
You can't combine them. Actually, you can't combine them when they're common factors.
If the last 3 digits are dividable by 8.
Last 3 digits.
Are divisible
So
by
let's say 6, 2, 5, 2.
So it's last 1 digit for 2, 2 digits for 4, 3 digits for 8.
8, 1.
And the reason you can't combine 2 and 4 is because when we combine the stuff before, there are no common factors. Like when you combine 10 is 2 and 5 together. Oh, sorry, 6 is 2 and 3. 2 and 3 don't have any common factors between them. But 2 and 4 have common factors. So when you have common factors, you can't combine the rules. Okay, we'll learn cofactors later on, common factors, but I think you already probably know it, right? 2 and 3 have no common factors except 1. 1's the highest, but that's not really mean everything has 1.
Yeah.
So now I'm going to prove these actually quickly. Proof for 2 is obvious. I'm going to prove it. I'm going to prove the divisibility rule for 4, right? Let's say I have like a really big number 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. and then 12 at the end. Right?
Yeah, yeah.
You agree? Some 1, 3, 1, 2, 3, right? Let's say I got rid of the last two digits. I'm going to split it up into two things, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 0, 0. Right?
Mhm,
And then plus 12. I'll just put the 12 with the rest of the number, right?
Yeah, yeah.
Is this number a multiple of 4?
Yes, yes.
Why?
Because the last two digits divide by 4.
Sorry?
The last two digits divide by
Oh,
4.
so we're trying to prove the rule, so we can't use the rule. So we're trying to prove that the rule is true. So we don't know yet. Let's say we pretend we don't know the rule yet. Trying to prove it's true. So we have to know in a different way. This is 100 times something, right? 2 zeros means 100 times this number. This number times 100. Do you agree?
Yeah, yeah.
Is 100 a multiple of 4?
No,
Yeah.
no.
100 divided by 4 is 25, right?
Oh.
So it is.
Oh yeah.
So this thing is multiple of 4.
Yeah.
So for the whole thing to be multiple of 4, the number you add also needs to be multiple of 4. Does that make sense?
Yeah.
So this part needs to be multiple of 4. Because it's always guaranteed that the part with the 2 zeros, multiple, because 100 is always a multiple of 4. So you need to check the last two, because and if it's a multiple of 4, then the whole thing's a multiple of 4. So 12 would work.
So if you have like 65, 9, and 8, 6, 4.
Yep.
But that'll be divisible by
864, you need to check the last 3 digits. For 8, you need to check the last 3. I think 864 is divisible by 8. So yeah.
64 is divisible by 8.
No, but you need to check the last 3. This is only for 4. Last 2 digits only for 4.
Wait, last 3 digits are?
Last 2 digits. For the multiple rule for 4 is last 2 digits is divisible by 4.
Yeah,
But for 8, it's last 3 digits.
it's for 8.
4, 8. But we need 3 digits.
3 means that
I'm sorry, I'm a bit confused. So what's the number you gave?
So 864.
864. So you got to check the last 2 digits, which is 864. Check if that's a multiple of 8.
Yeah, 864.
Yeah, we check that, and if it's a multiple of 8, yes. If not, no.
4 is a multiple of 8.
Yeah, it is multiple of 8. So yeah. But the key idea here is really important. Because when you have 2 zeros, something like times 100 is a multiple of 4. The number you add to that, which is the last 2 digits, is what's determines if it's a multiple of 4. Remember when we did like this addition rule stuff? It's sort of like the first number is already like the one that's already we know is a multiple of 4. All that matters is we're checking if the second number is a multiple of 4. And the second number is sort of the last 2 digits. And the same thing for divisible by 8. Is 100 divisible by 8?
No.
No. What about 1000?
No.
Yes.
135.
Yeah, it's 125 actually. So 1000 is divisible by 8. Right? That means the last 3 digits, if you exclude the last 3 digits, it's going to be multiple by 8. So like something 476,000. This number is a multiple of 1000, right? Because 3 zeros at the end.
Yeah.
That means this is already a multiple of 8. So for the whole thing to be multiple of 8, you need whatever the last 3 digits are, let's say like 762, to be multiple of 8. Right? Does that make sense? So if this is not a multiple of 8, no, I don't think this is. So it fails the test. Right. But another thing is, if a number is not a multiple of 2 or 4, then it's obviously not a multiple of 8 as well. Does that make sense?
Yeah.
All right, let's do an example together. Right? We're going to determine whether the following number is a multiple of 2, 4, and 8, all of them, right? And division is not allowed.
I didn't see that.
So if you do it, you can do it long division, but it's very long. right? So let's do it together. So to check if it's a multiple of 2, what do you need to do?
Check last number.
Is it-
You have to check if the last digit is divisible by 2.
Yeah.
The
It's
full
The people
six.
the same. Or
So
zero.
it's
Or
6,
zero.
so it's even, therefore it's yes. 10:30. Yeah, and for 4, what do you check?
4, you have to make sure that the last digit is divisible by 4.
Yeah, good. 36. 36, 4 times 9, yes. Yeah. And what about if it's a multiple of 8?
The last three digits have to by 4.
Is it? Is it a multiple of 8?
8.
Is it? Check. Let's check it, right? 836 divided by 8.
76, died for the brain.
7, 6.
20 died, 200
Yeah. No.
I don't know which one it is.
8 times 9, 72. It's not, right? Yeah, very good, Oliver. It's no. The remainder is 4 here. So therefore it's not. Right? Now I want you to do some on your own. So let's just do a few. Let's do A, C, and E. Question 15.
I have question A.
Yep.
Well, how what does it work if actually no.
If it's less than 3 digits, you can just check the last 2 digits. Like if it's 3, you can just think the first number is 0.
Okay. What are we doing? A, C, and E.
A, C, and E.
Okay.
Possible for doing multiple 8 and non multiple.
Oh, yeah. About that 4 goes into 32.
Everything else, I'll check the PDF. By the way, it's not if it's not 2, it's not the rest.
Yeah.
It's odd, it can't be 4 either. Italian ones or you going forward already? Well, we're doing the quiz at 10:45. Do you have access to the quiz?
Wait.
You still walking? Toilet?
So just before like the chairs over there, to the left before that.
The one over there or here?
No, just go straight to the empty room right before that the door. Okay. Is it over there? No, it's to the right. There's no-
I have challenge problem.
Sachin.
I don't think I have.
Yeah, sorry, what did you say, Oliver?
I have challenge question. Quiz.
You've done the questions? Or do you have a question?
Challenge question.
Helen's question.
Yeah,
Okay.
yeah.
All right, let's quickly go over this one then, because right, the answers are yes, yes, no.
Yep.
Okay. And for C, it's yes, yes, yes. Because the last digit is all we care about. And then for E, it's no.
So actually, I figured out if the digit is odd, then it can't be 2, 4, or 8.
Which one, sorry?
If the last digit is odd, it can't be divided by unended.
Yeah. If it's odd, none of them will work, right?
Yeah.
If it's not 2, it doesn't work for the other 2 as well.
Pardon?
So like if you hit a no early on, the rest is going to be no as well. If you hit a no at 4, the rest is also going to be no.
Alright.
Because if it's not a multiple of 4, it can't be multiple of 8 either. Alright, let's go to divisibility rule for 5 and 10. Right? These are pretty easy. Numbers divisible by 5 if
0, 5.
last digit is 0, 5. And the 10 would be Mal.
Last digit 0.
Yeah. All right.
I had the same start they did those questions before I left.
Okay. Proof, we're not going to go there. We're going to go to a quick example. You can check whether the following numbers is a multiple of 5 and 10. Right? Is this number a multiple of 5?
Yes.
Yes, 10.
Yes.
Yeah, pretty easy.
Yes, also.
Yes. I'll quickly go through them. Give you a minute to do A, B, A, C, any. Should be speed run. Take a look. Should be good. I'll take a look at ACE.
Oh.
Pretty fast.
It's not. Oh, yes, it is.
By the way, if anything, if there's no at the start, the rest is always going to be no. So you can't have a yes at 10 and no at 5. Because if it's a multiple of 10, it's also a multiple of 5.
If 10 is a yes, then 5 is a yes.
Yeah.
But if 5 is a no, then 10 is a no.
Yeah.
And if 5 is a yes,
If 5 is yes, 10 might be yes or no, we don't know.
Yeah. So like if it ends at 5, then 0 and 10 no.
Yeah, exactly. Good. All right, so we're gonna quickly go over the answers. It's yes, no, 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 and E would be yes, yes. The answer to the rest as well. Yes, no. It's for F. D is yes, yes, and no, no for B. Right. Okay, this is a little bit tricky one, so I want you to practice this one before we finish. Is
Sum of its digits.
so you might tell me the one for divisible by 3.
Sum of its digits is divisible by 3.
So the way I think the way 3 works is that if the last digit first digit is plus not itself,
Yep.
then it's equal, that is divisible by 3. Like if it plus.
Sorry, could you repeat that?
9, 11, 13, 14 division, 18,
So if it's divisible by 6, it's same as 3, but you're also going to check if it's what? If it's even, if it's divisible by 2 as well. So combine rule for 3 and 2. Sorry, Oliver, I missed what you said. I couldn't. It's a bit unclear for some reason.
So basically,
Yeah.
So if a number lost two digits,
Yep.
plus each other, and
Yep.
they are divisible by 6, That means you can divide. That means the number.
Wait, could you type
then
that
it-
in?
and then
It's a bit unclear. Right?
How do I?
I'm gonna do check if it's about 9 now. Oh, just on the chat, just say to me, to the host account, send it to me. And we'll go to divisible by 9 now. A number is divisible by 9 if the sum of its digits is also divisible by 9.
32.
Now that you know this, can you do the example? Let's do the example together. Right? All right, let's do the example together. Right, so check if it's divisible by 3. What do you need to do here, Imal?
See if the digits are 6.
Yeah, so what is the sum of the digits? It's a bit tricky. I have to add them all.
Twelve, 19, 34, 32, 36, 38. 45,
It's a lot more. So let's go through them together.
12,
2 plus 3 is 5. Plus 4 is 9. Plus 2, that will be 11. Plus 3 is 14.
12,
Plus 9,
28,
23. Yeah. 0 doesn't do anything. Plus 4, 27.
31,
3,
37, 45,
32.
53.
Add 3, sorry, 29, add 3, 32. Then 6.
So 7.
No? 29 plus 3 is 32 here. Plus 6, 38. Plus 7, 45.
Yeah. It's yes, no, yes.
No, Olive, actually, you need all the numbers, not the last 3.
Okay.
So it's not the last 3, it's every single.
That is good.
Wait, hang on.
Just give me a second, I'll just quickly go through this one. I'll take a look after it. Do the challenges. So it will be yes for 3. What about 6? Why?
Because it's not the
Yeah, no. And then 9?
yes.
Yep, good. So it's yes, no, yes.
Hang on, I'm confused.
So yeah. So which one's part's confusing you? Yeah, go to the example you exercise yourself now. Yeah, do the you're doing the next page. Yep. So what was the question you had? Which part's confusing?
Just the way to do it.
The rule?
Yeah.
Oh, which one? 3, 6, or 9?
All of them.
All of them.
Yeah,
So the proof for these are actually really tricky. But here's sort of, if you recognize, right? Look at all the multiples of 3. 3, 6, 9, 12, 15, 18, 21. If you look at all of them digit sums, this is 3, this is 6, this is 9. 1 plus 2 is 3. 1 plus 5 is 6. Plus 8 is 9. It's a repeating pattern.
Okay.
All of these digit sums are like 3, 6, 9 and multiple of 3.
Yeah.
And this pattern will continue.
Okay.
Basically forever, not necessarily, but goes pretty long for a long time, right?
Yeah.
So from this pattern, I realized that all multiples of 3 have the sum of the digits divisible by 3.
Okay.
Add up the digits together, it's divisible by 3. And for 9, if you add up the digits together, it's divisible by 9. Because look, 9, 18, 27, all that's up to 9, but later on it'll add up to bigger numbers that are divisible by 9.
Okay.
That's the pattern. Proof is really hard. It's actually really, really complicated proof. But do you see the pattern? How it's going to always be 9? You can keep trying other numbers, but you always say that it's 9.
Yeah.
Right? And then for divisible by 6, you just got to check the divisibility rule for 3, right? Because 6 is part of 6 is 2 times 3, right? So you gotta check the divisibility rule for 3, which is the number, some of the numbers is divisible by 3. And then after that, you just gotta check if it's even. Wait, sorry, give me a second. I think you'd add that second.
What's your name?
Haley.
Oh, okay. You? I'll go to that's right. That's right. Do you know Beverly Gardens? Beverly
Oh,
Gardens?
oh,
It's like, you know Shahan? It's not your way.
Oh wait. कार्ड के गेम में स्पोर्ट्स बैग स्पोर्ट्स बैग देते हो नाइकी इस तरह की हां फोटो वाला दे Okay, sorry about that, guys. We'll go to. I'll continue explaining this. Sorry about that, Oliver. Divisible by 6, right? This 3 and 9 makes sense. Yeah. So 6 is just the same as divisible by 3, except it's even. All because 6 is an even number, all the multiples are even as well. So all you need to do is check if it's divisible by 3, but then on top of that, check if it's even, which is divisible by 2. Does that make sense? So for example, like 33, right? If you check the digit sum, it's 6. That's multiple of 3. That's divisible by 3. That's fine. But is 33 even or odd? Odd. Therefore, it's not a multiple of 6.
Okay.
Yeah. Does that make sense?
Yes.
Yeah. All right. So that's what we did here. We just checked that the digit sum is 45, right? 45 is divisible by 3. So therefore, yes, for 3.
Okay.
But while 45 is divisible by 3, the last number is 7, which is odd. That means the overall thing is odd. It can't be multiple of 6. So it's no for 6. And 45 check is divisible by 9, which it is. Therefore, yes, you say yes for that. It is divisible by. Yes, no, yes. All right. So I want you to continue with these exercises yourself, but because we run out of time, we'll do the quiz now. And probably try to do this for homework, okay? These exercises, do ACE. And actually, I'll take a look at your answers for this ACE. I'll give you the quiz. Yeah, I'll take a look. Just, Okay, so Oliver, we're doing the quiz now. Do you have access to it?
Yeah. I'm on.
Okay, good. Actually, let me get the quiz out. Can you should do the challenge problem? not the correct quiz.
Yeah, because this would be last week's quiz.
Yeah, I think it's last week's quiz.
Do you continue or are you giving us a new one?
No, that's right. That's right.
Oh.
The one I have up is the wrong one.
Oh.
Your one's good.
All I supposed
On my
to
screen is
follow
wrong.
through.
Oh, never mind. Sorry.
Sorry? I've got the wrong one.
Nothing.
This one's the correct one.
5 divided is negative 5 plus 17.
So what was that? Oliver, did you have access to the quiz, or was that like?
Yeah, I have access.
Okay, good. All right. Oh, I lost it.
Oh no.
One of them must say so, except the first one.
I put it just there with my homework.
This one, 26. That's the correct opinion. But we had 7, 26 plus 7. Everything else is after that. The rest is no. Is it divisible by 3? No, it's got to be divisible.
Oh yeah, because it has to be.
45 divided by 3 is also 50. If you have any questions with the quiz, let me know.
I don't know how to do G.
G? G is tricky, but very similar to the tricky one from last week. How many times are you
3.
adding?
3.
So if you're adding 3 times, it's
What is it like this? 3.
not to the power. Addition repeatedly, same as
Times.
times.
With this time. Oh, so it would just be 1, 3, 8 times 3. But that would that to be 3 to the power 7?
No. It's negative 8 times 3 to the power 1.
Negative 8. Wait, I don't get it.
It's times 3. 3 is same as 3 to the power 1, right? 3 is just 3 to the power 1.
I don't understand that part.
3 to the power 1 is equal to what?
3 to the power.
Any number to the power
3.
1 is 3. So 3 is the same as 3 to the power 1. So you have 3 to the negative 8 times 3 is the same as 3 to the negative 8 times 3 to the power 1.
Oh, so negative times.
You can do it this way as well, but this one's kind of ugly.
3.
It's a big division, but. And it's up being 3 to 7 at the bottom. There's 1 and 3 to 7. It's 3 to the power negative 7. That way. You do it that way. Because the denominator is bigger there.
negative power of 6. So that is 2. Do I just do 49 for this one, or do I leave it like that?
29.
16, 1, 3, I can't do them soon.
Oh, be careful. Is it really about 3 there? No, I need 3 about 1. You did the steps correctly, you just gotta be. You understood how to do it.
2 times 3 times 3 is 81. 81 times 1, 8, 8, 12.
Try not to do brutally.
1, 5, 6.
Don't do it that way. You're gonna click the answer. But,
Wait, so do I have to change everything else?
Okay.
27. What's that?
Oh, yeah. Well, it would be.
You also gotta change the 27. 27 to the power 1. Change the font from there. That's you. It's an easier way to do that.
2 times 3 squared, 3, 6. So what does
That's division, right?
so the roots multiplication?
Multiplication by the reciprocal, same as division.
Yeah,
It's like 3 to 7 divided by 3 to 6.
so it'll be just 3. Okay, what is poetry?
Oh, this was in the homework.
Something like this. This page. 4 times 4 times 64.
Alright, guys, 4 minutes left.
8 times 8 is 64. I'll just
I'll take a look.
finish.
Good. Alright, let me mark it.
I don't care.
Do challenging ones in
Yeah,
the
yeah.
last 4 minutes.
Okay.
What did I do here?
So you want to, oh sorry, convert it to a positive power.
Oh.
And then also if you get rid of the powers, like express like a 4 number answer.
Oh, so
For this question, negative powers are reciprocals. Express as like a whole number answer. It's all whole numbers. So no powers. Well, that's wrong. Yeah, it's my bad. See you.
no, that's mine.
That's yours. Oh,
My handwriting's not that deep.
this one you don't need to actually find the number. I want to leave it. I want to leave it as power of 4.
You corrected my quiz last week.
Oh no, the quiz homework.
Yeah, the homework quiz.
They're just homework problems. It's on Google Classroom. I didn't give hard copy. It's on Google Classroom. I think I texted you.
I read the ones.
Yeah, that's fine. So normally homework's on Google Classroom.
Yeah.
So you just do it on Google, do it there, and like maybe bring it like this, or submit it on Google Classroom.
Okay. So if I want, I will just print it out and do it.
I haven't uploaded homework for this week yet, but I'll upload it tomorrow probably.
Pardon.
Yep.
10 a.m. 10 a.m. I
Done.
mean 11 for you.
Sorry.
For you, it's 11 a.m.
It's 11
a.m. for me.
11 a.m. Oh yeah. You finished?
No, I'm still struggling.
If you want a quick hint or something, I can help you out before you go. Because don't worry if you can't finish, by the way. I don't expect you guys to finish this. It's meant to be tricky. It's about giving the tricky questions a go. So we've got another 2 minutes and then finish the class day. You can submit the quiz on Google Classroom. I might not have marked it last week because I had an exam, but
You see always on that?
I'll mark your quiz as well.
It's
Sorry?
11:03. 11:03.
Yeah, you can. We finished. If you want to, you want to go. You can go if you want. I can just submit the quiz online and I'll mark it. All right.
Okay.
All right. Okay, I'll see you next week and submit the quiz online. I'll mark it. Okay. You can go a bit longer if you want to at home. It's fine. It's fine by me. Okay. All right. I'll see you next week. Okay. Bye. It's gone. As soon as I go again. All right. Did it? Yeah, but the students, right? Actually, are. Think that.
Oh, this makes sense. 2 times 2 is 4, 4 times 1 is 6, 3 times 1 is 64.
Mm-hmm. Times 5.
2 times 2 times 2 is 4, 4 times 4 is 16, 30.